Assalamu alaikum dear students, welcome to nuclear physics lecture. In today's lecture we will talk about cyclotrons. I'm Dr. Pervez Ahmad, so let's start with today's lecture. What is a cyclotron? Just like you can see it here in this particular figure, a cyclotron consists of two large dipole magnet. The role of these large dipole magnet is basically they are being designed to produce a semicircular regions of uniform magnetic field. Now, what we have to do with these uniform magnetic field, I mean, it's they're basically their aim is to pointing uniformly. We have a semicircular region of uniformly magnetic field pointing uniformly downwards. I mean, this is the basic. We are describing the basic structure of the cyclotrons. So, what is the basic structure of the cyclotron look like? I mean exactly the ones you can see it in the figure. So what we have, we're saying that it consists of two large dipole magnet designed to produce a semicircular regions of uniform magnetic field pointing uniformly downwards. So along with that, you can see it here. These are called the D's because of their D shapes. I mean here you can see in the mirrors that there is the D shape structures. So these are called D's because of their shapes. I mean if you look at clearly at their shapes, so they look like exactly the English alphabet D's, and they're also called D's. So the two D's are placed back to back with their straight side parallel, but slightly separated. I mean here you can see it. The other two D's it's been placed back to back with their straight side, but it's been separated by a slight distance, by a small distance. So what actually we do at a cyclotron, uh, we have an oscillating voltage, and that is being applied to produce the electric field across this gap. I mean here we say that there is a gap between the two D's, so we apply an accelerating voltage. So this accelerating voltage produces an electric field across the gap. So particle injected into the magnetic field regions of a D trace out a semi circular path until they reach the gap. I mean here we are mentioning about the particle. So what actually we do, uh, particle injected into the magnetic field. I mean first we inject the particle into the magnetic field regions of a D trace. uh, 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 so what actually they do, it traces out a semicircular path until they reach the gap. So when they reach the gap, so the electric field and the gap can accelerate the particle as they passes across it. I mean the particle they've been circling around until it reach this particular gap, and when it reach this particular location, so here we applying the electric field. So this electric field basically accelerate the particle as they passes across it. So what happened next? The particles now have higher energy, so that they follow a semicircular path and the next D with a larger radius, and so reaches the gap again. So after that, again the electric field frequency must be just right, so that the direction of the field has reversed by the time of arrival at the gap. So the field in the gap accelerate them, and they enter the first D again. So thus the particles gain energy as they spiral around. I mean you can see it here. The particle is spiral around. I mean through the first D and then through the second D. So the track is that they speed up. They trace a larger arc, and So they always take the same time to reach the gap. I mean, whether it started from the first year, from the secondary, so it take the same time to reach the gap between these two Ds. This way, constant frequency electric field oscillation continues to always accelerate them across the gap. But here we have the limitations. The limitation on the energy that can be reached in such a device depend upon the size of the magnet that form the Ds and the strength of their magnetic field. I mean, this is a short description of the cyclotrons and how we accelerate the particles inside the cyclotron. There have been some mathematics involved that you people already know in your basic physics classes, where we're not been going to discuss those equations by which we can accelerate the particle. I mean, so we have simple relation just I mean, for the acceleration of the particle in cyclotron, which we can get by just balancing equalizing the electric field with the magnetic field, and with that we can get a simple relation for the acceleration of the particle and the cyclotron. So this is a brief view, a brief discussion about the cyclotron. Hope you get the basic idea. So this is all we have for the cyclotron. See you in the next lecture.